Tapping an existing electrical service involves two critical considerations. Firstly, obtaining special permission, and secondly, utilizing approved materials for the connection. Addressing the concept of tapping into an existing electrical service, it is vital to consider the requirements outlined in the National Electrical Code, specifically sections 230.33 and 230.46, along with other relevant sections such as 240.2. The practice of tapping a service, which involves drawing power from an existing service entrance to supply a new location or load, is permissible under certain conditions but necessitates adherence to stringent guidelines to ensure safety and compliance. One of the primary aspects to consider when contemplating a service tap is the necessity for special permission. This permission typically comes from the local authority having jurisdiction, which could be the city or county electrical inspector or the utility company. Obtaining this permission is not merely a formality, it is a crucial step to verify that the proposed tap adheres to local codes, regulations, and safety standards. The authority having jurisdiction will evaluate factors such as the existing service capacity, the proposed load addition, and the overall impact on the electrical grid. They may also require detailed plans and specifications to ensure that the tap is executed safely and effectively. Moreover, they might impose specific requirements regarding grounding, overcurrent protection, and disconnect means to mitigate potential hazards. Therefore, it is imperative to consult with the authority having jurisdiction early in the planning process to understand their specific requirements and obtain the necessary approvals before proceeding with any physical work. The second critical consideration is the utilization of approved materials for the connection. The term approved materials refers to electrical equipment, conductors, and components that have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. These materials are designed and manufactured to meet specific safety standards and performance requirements, ensuring that they can withstand the rigors of electrical service without posing a risk of fire, electrical shock, or equipment failure. When selecting materials for a service tap, it is crucial to choose components that are appropriate for the intended application and that are listed for use in the specific environment. For example, if the tap is located outdoors or in a wet location, weatherproof enclosures and connectors must be used to protect the electrical connections from moisture and corrosion. Similarly, the conductors used for the tap must be sized appropriately to handle the anticipated load current, taking into account factors such as ambient temperature, conductor insulation type, and conduit fill. Furthermore, all materials must be installed in accordance with the manufacturer's instructions and the applicable requirements of the National Electrical Code. This includes proper termination techniques, torque specifications, and support methods. The use of substandard or unapproved materials can compromise the safety and reliability of the electrical system and may result in code violations, fines, or even legal liability. In addition to special permission and approved materials, several other factors should be considered when tapping an existing electrical service. Firstly, the existing service capacity must be evaluated to ensure that it is adequate to handle the additional load imposed by the tap. This evaluation should take into account the existing load in the service, the anticipated load of the new location or equipment, and any potential for future load growth. If the existing service is not sufficient to handle the additional load, it may be necessary to upgrade the service entrance to a larger capacity. Secondly, proper overcurrent protection must be provided for the tap. This typically involves installing a circuit breaker or fuse at the point where the tap is made to protect the conductors and equipment downstream from overloads and short circuits. The overcurrent protection device must be sized appropriately for the ampacity of the conductors and the rating of the equipment it serves. Thirdly, a disconnect means must be provided at the new location to allow for convenient and safe disconnection of power for maintenance or emergency purposes. The disconnect means should be readily accessible and clearly labeled to indicate its purpose. Furthermore, proper grounding and bonding are essential to ensure electrical safety. The grounding system must be installed in accordance with the requirements of the National Electrical Code to provide a low impedance path for fault currents and to minimize the risk of electrical shock. Bonding involves connecting all non-current carrying metal parts of the electrical system together to create an equipotential plane, which helps to reduce voltage differences and prevent electrical shock hazards. Another critical aspect to address is compliance with National Electrical Code Section 240.2, which pertains to the protection of conductors. This section mandates that conductors shall be protected against overcurrent in accordance with their ampacities, which are determined by factors such as conductor size, insulation type, and ambient temperature. Failure to comply with this requirement can result in conductor overheating, insulation damage, and potentially fire hazards. Therefore, it is crucial to carefully select and size conductors and overcurrent protection devices to ensure compliance with National Electrical Code Section 240.2. Furthermore, it is important to consider the impact of the service tap on the overall electrical system. Tapping a service can affect the voltage drop, impedance, and fault current levels throughout the system. These changes can impact the performance and safety of other equipment connected to the service. Therefore, it is essential to perform a thorough analysis of the electrical system to identify any potential issues and to implement appropriate mitigation measures. This analysis may involve calculating voltage drop, performing fault current studies, and evaluating the impact on protective device coordination. In addition to the technical considerations, it is also important to address any potential legal or contractual issues associated with tapping an existing electrical service. This may involve obtaining easements or rights of way from property owners, negotiating agreements with the utility company, and complying with any applicable building codes or zoning regulations. Failure to address these issues can result in delays, legal disputes, or even the removal of the service tap. To ensure a safe and compliant service tap, it is recommended to engage the services of a qualified electrical contractor. A qualified electrical contractor has the knowledge, experience, and equipment necessary to perform the work safely and effectively. They can also assist with obtaining the necessary permits and approvals and ensuring compliance with all applicable codes and regulations. When selecting an electrical contractor, it is important to verify their credentials, check their references, and review their insurance coverage. It is also advisable to obtain multiple bids to ensure that you are getting a fair price for the work. In summary, tapping an existing electrical service requires careful planning, execution, and compliance with applicable codes and regulations. Special permission from the authority having jurisdiction is typically required, and approved materials must be used for the connection. Additionally, the existing service capacity must be evaluated, proper overcurrent protection and disconnect means must be provided, and proper grounding and bonding must be implemented. Compliance with National Electrical Code Section 240.2 is essential, and the impact of the service tap on the overall electrical system must be considered. By addressing these factors and engaging the services of a qualified electrical contractor, you can ensure a safe, reliable, and code-compliant service tap. Furthermore, it's important to consider the specific requirements outlined in Article 230 of the National Electrical Code, which covers service entrances. This article provides detailed guidelines for the installation, sizing, and protection of service conductors, equipment, and disconnecting means. Some key considerations from Article 230 include the following. Firstly, the service conductors must have sufficient ampacity to carry the calculated load. Secondly, the service disconnecting means must be readily accessible and capable of disconnecting all ungrounded conductors. Thirdly, the service equipment must be suitable for the available fault current. Fourthly, the service grounding system must be installed in accordance with Article 250 of the National Electrical Code. In addition to Article 230, other relevant articles of the National Electrical Code may also apply to a service tap. For example, Article 310 covers conductors for general wiring, Article 314 covers junction boxes and pull boxes, and Article 408 covers switchboards and panel boards. It is important to consult all applicable articles of the National Electrical Code to ensure that the service tap complies with all requirements. Moreover, it is crucial to understand the concept of service entrance equipment, which typically includes the service disconnect, overcurrent protection devices, and metering equipment. The service entrance equipment must be properly sized and installed to handle the anticipated load and fault current. The service disconnect must be readily accessible and capable of disconnecting all ungrounded conductors. The overcurrent protection devices must be sized appropriately to protect the service conductors and equipment from overloads and short circuits. The metering equipment must be installed in accordance with the utility company's requirements. Furthermore, it is essential to consider the environmental conditions in which the service tap will be installed. If the service tap is located in a wet or corrosive environment, special precautions must be taken to protect the electrical equipment from moisture and corrosion. This may involve using weatherproof enclosures, corrosion-resistant materials, and proper sealing techniques. Additionally, it is important to ensure that the service tap is properly protected from physical damage. This may involve installing the electrical equipment in a secure location, using conduit to protect the conductors, and providing barriers to prevent accidental contact. Another important aspect to consider is the coordination of protective devices. Protective device coordination involves selecting and setting overcurrent protection devices so that they operate in a coordinated manner to minimize the extent of an outage. This means that the overcurrent protection device closest to the fault should trip first, while the upstream devices remain closed. Proper protective device coordination helps to prevent unnecessary outages and minimizes the risk of equipment damage. In addition to the National Electrical Code, other codes and standards may also apply to a service tap. These may include local building codes, fire codes, and utility company standards. It is important to consult all applicable codes and standards to ensure that the service tap complies with all requirements. Furthermore, it is essential to document all aspects of the service tap, including the design, installation, and testing. This documentation should include detailed drawings, specifications, and calculations. The documentation should be kept in a safe place and should be readily available for future reference. In conclusion, tapping an existing electrical service is a complex task that requires careful planning, execution, and compliance with applicable codes and regulations. Special permission from the authority having jurisdiction is typically required, and approved materials must be used for the connection. Additionally, the existing service capacity must be evaluated, proper overcurrent protection and disconnect means must be provided, and proper grounding and bonding must be implemented. Compliance with National Electrical Code Section 240.2 is essential, and the impact of the service tap on the overall electrical system must be considered. By addressing these factors and engaging the services of a qualified electrical contractor, you can ensure a safe, reliable, and code-compliant service tap.